Hey, we're going to begin moving into Chapter 6. Chapter 6 is going to kick us off with our units that will be basically about geometry. We're going to talk about triangles in Chapter 6, in Chapter 7 quadrilaterals, and then we'll do a chapter on circles. So, there are some things that I needed us to remember, or some topics that I wanted to make sure we recalled before we moved into the triangle unit too significantly. So we're going to do just a couple of review things. One of those being proportions and another one being about triangle congruence. So you solved proportions probably back in middle school. At some point in time, a proportion was the setup of two fractions that are equal to one another. And that means that their cross products are also equal. So 8 times n would have the same value as 3 times 192, and that's how you would solve these. So we would set up one cross product, then the equal sign, and then the other cross product. It doesn't matter what order you put those in, since order doesn't matter when you multiply. So 8 times n is 8n, and 192 times 3 is 576. Then to solve that for n, we're going to divide both sides by 8, and when we get done, we realize that n is 72. We're going to, of course, make those a little bit more complicated because it is math too, but we'll start out with some pretty easy ones. So here one of our cross products would be 8 times n, and the other one would be, 10 times 10. So 8n is 8n, and 10 times 10 is 100. Then we're going to divide that by 8. And n is going to equal something. Now that something might be a decimal, and this is one of those rare occasions where Mrs. Fleming's going to tell you it's okay if you want to be able to put a decimal down. So 100 divided by 8 is 12.5, and I won't make you reduce that in improper fraction and all that kind of stuff. We're just going to leave it as 12.5. All right, the second one, we have 2x and 6 as one of our cross products. And the other one, 10 times 9. So 2x times 6 would be 12x, and 10 times 9 would be 90. So to get x alone, we'll need to divide by that 12. And I guess I should have probably on the other one, it equaled exactly 12.5. I don't know that this one's going to divide nicely. Oh, it does, so I can still use an equal sign because we get 7.5. It terminates or ends. It doesn't continue filling up my calculator screen with a whole lot of values. So we can put equals as long as it truncates is what we call it. Number 3, one of our cross products would be 18 and 7. And the other one would be 14 and 3a. So we'll need to do 18 times 7, which is 126. And 14 times 3 is 42a. Then we're going to need to divide by 42 to get a alone. Remember, it doesn't matter which side of the equal sign your variable is at. Just leave it wherever it is. And when we divide that, we get 3 as our value for a. Nice whole number answer on that one. All right, let's take it up to a little bit of a more math 2 type of question. So one of our cross products will be 8 and m minus 8. And you'll notice I took the binomial and I put it into parentheses so that I could multiply. Then 4 times 2 is our other cross product. When we multiply the number times the binomial, we will need to do distribution. So 8 times m would be 8m, and 8 times negative 8, negative 64. Then 4 times 2 is 8. To get m alone, though, we'll have to do more than just divide by 8. We also need to add that 64. So now we get 8m equals 72. Then we can divide by our 8, and we should get m equaling 9. Again, that nice whole number answer. Let's try another one similar to that. One of our cross products is 7 and 5. And the other is b plus 5 and 10. So I'm going to put the 10 in the front so I can put b plus 5 in parentheses. 7 times 5 is 35. Then we'll need to distribute the 10 into our binomial. So 10 times b is 10b. And 10 times 5 is 50. To get b alone, we'll need to do more than just divide by 10. We'll have to start by subtracting the 50. So we get negative 15 is equal to 10b. Then we can divide by our 10, And let's see, negative 1.5 would be the value of b. Again, because it truncated, I don't need to use approximately, I can use the equal sign. And then our last one, 9 and c, is one cross product. And 7 and c minus 10 as a binomial is our other cross product. So 9 times c is 9c, 7 times c is 7c, and 7 times negative 10 is negative 70. And you'll notice we end up with a variable on each side of the equal sign, and that's okay. That's not a problem. We're just going to collect our like terms like we normally would. 9c minus 7c is 2c. 7c minus 7c is 0. This part's gone. Equals negative 70. To get c alone, we'll divide by 2. And c would be negative 35. We should also be able to set up those proportions from a word problem. So we're going to look at a model train. It says a model train has a scale of 1.2 inches to 2.9 feet. If the model train is 5 inches tall, how tall is the real train? So when we set up a proportion, we do want to make sure we keep it consistent. So I'm going to do scale over real. And I suggest to you, if you struggle with this at all, please write down what it is you're going to put on the top and what you're going to put on the bottom. So the ratio for this would be 1.2 inches is relative to 2.9 feet. And it says the model train is 5 inches tall. So remember we did inches over feet. So we're going to have 5 inches here. And what we don't know is how many feet that is in real life. So we'll use our cross products. One of those would be 2.9 times 5. And the other one will be 1.2 times, we don't know, so I'll use an x there. And then we'll need to do 2.9 times 5, and we get 14.5. And 1.2 times x would be 1.2x. So we would divide by 1.2 to get x alone. And we get 12, pencils running out, 12.083 repeating as the value for x. So how long is the real train? Well, we're going to approximately here 12, and that label should have feet. So 12 feet would be the real train car that was supposed to be modeling. The second topic that I want us to review is triangle congruence. So hopefully you will remember that there are 5 ways to show that triangles are congruent to one another, and they have 3-letter abbreviations. One of them is side, side, side. So that would be an indication that we have 2 triangles, each with the same side markings. So 1 tick mark, 2 tick marks, 3 tick marks. All 3 sides are the same length, so therefore those triangles would have to be congruent. Another is side, angle, side. You'll notice the A is between those 2 S's because that's the way it needs to be in your picture. It has to be the included angle. That means the angle that is touching or in between or made by each of the sides that are marked. So here we have 1 tick mark and 2 tick marks, and it is the angle that's marked that is between or included or formed by the 2 sides that are marked, and the same thing happens in this triangle as well. And then we have the 2 that have to do with 2 angles and a side, one of them being angle, side, angle. Again, you'll notice the S is between the 2 A's. That's because it needs to be the side that's between the 2 angles or touching both of the angles. So here we have an angle with 2 tick marks, another one in the other triangle, angle with 1 tick mark, angle with 1 tick mark, and a side with 1 tick mark. And that is the side that, if you continue it out, touches each of the 2 angles that are marked. And on this one, if we continue that side out, it is the one that touches each of the 2 angles that are marked. Then we have the angle, angle side, and you'll notice here S is at the back. And that's there on purpose because we have angle, angle, and then a non-included side, meaning not the side between the 2 angles. So we have an 1 tick mark angle and 1 tick mark angle, 2 tick mark angles, 2 tick mark angles, a side and a side. And if we take that side and touch it, it does not touch one of the marked angles. It does touch one of them, but then this angle up here is not marked. The same thing, this one touches the 2 tick marks, but not the other one. So this would be angle, angle, side with the non-included side. And then the last one, it actually uses 3 pieces of information, but we just name it with 2 because it is the hypotenuse leg. But a hypotenuse can only exist in a right triangle. So really, it has to have that 90-degree angle marking in it, so that makes 3 things marked on the triangle. So right angle, and then this 2 tick mark, that's on a leg, and then the 1 tick mark is on the hypotenuse. Remember, the hypotenuse is your longest side. It's the side that's across from the 90-degree angle or doesn't touch the 90-degree angle. So it has to have the hypotenuse marked and then another pair of legs that would be marked. Now when we were doing that, we did some CP/CTC in proofs to prove that the triangles were congruent, which meant the corresponding parts of those congruent triangles would be congruent. We practiced writing some congruent statements, so we're just going to fly through those real quickly, and then I'm going to give you a couple of examples as well just to make sure you remember. So triangle ABC, since A was listed first, we have to do its corresponding partner over here, which would be the 90 degrees, so that would be triangle D. Then B was listed, that has 2 tick marks, and E over here has 2 tick marks, so it has to be listed next. C was last, it has 1 tick mark, and F has 1 tick mark, so it should go last. And then here we have triangle CDE is going to be congruent to, so C is here with 1 tick mark, that would correspond with F. Next came D, that's here with these 2 tick marks, that's going to correspond with E over here that only has 2 tick marks. And last came E in this triangle, which has 3, and in the other triangle 3 occurs at D. Remember, you're looking at each triangle individually. So CDE, I needed to be sticking with this triangle as what I was looking for the order that they should go in. 1 tick mark, 2 tick marks, and 3 tick marks. And then the last one, triangle TUV, and that would be congruent to triangle. Since T went first, we need the other one with 1 tick mark, which would be W. U has 2 tick marks, that goes with X. And V has 3 tick marks, so that's going to go with the other side of V. So as I said, I wanted to give you a couple of examples, make sure we're on the right track with getting these correct. So here we have our 2 triangles, and we can see that we have 2 tick marks, 2 tick marks, 2 tick marks, or sorry, 1 tick mark, 1 tick mark, and then this shared side that is marked as congruent as well. So here we have an angle, here we have an angle, and here we have the side. So the options that have 2 angles in a side are angle, side, angle, and angle, angle, side. This is the side that touches both angles, so the S should go touching both of the A's. So angle, side, angle. This one over here, we have a side, an angle, and a side, an angle, and a side. So when we take a look at those, we have 2 S's and an A, and the only option that we have for that would be side, angle, side. It has to be the angle that touches both sides. Double check that in both triangles. So that would be side, angle, side. Looking at this one down here, we have vertical angles, and then we have this 1 tick mark and 1 tick mark. Then we have another side and another side. So we have an angle and another angle and a side. So our choices for that are angle, side, angle, and angle, angle, side. As we look at this particular example, it is not the side that touches both of the marked angles. So this one should be angle, angle, side. And then we look at this one here, and we have a side and an angle and another angle and a side and another angle and another angle. Please do not automatically assume because you see a right angle that it has to be a hypotenuse leg. That is not necessarily the case, like in this one. This has the hypotenuse marked, but there is no leg marked, so it can't be hypotenuse leg. Instead, it has to be angle, angle, side. Since this is not the side that touches both angles, the S would not go in the middle, so angle, angle, side. And I have 2 more over here. Here we have 2 tick marks, 2 tick marks, 1 tick mark, 1 tick mark, and then this shared side. Everything that's marked is a side. There's no angles marked, so we have side, side, side. And then we have this diagram here with these right angles, and then we have a side, a side, a side, and a side. So if I wrote my letters on there, that's a bad word, and I don't want to do that, so we can't use those 3 letters in combination, but we do have the hypotenuse marked on each of these, and then an additional leg, and because it is a right angle, we are looking at hypotenuse leg. I am going to throw an extra video onto Schoology for you to have a glance at today if you're struggling with the triangle congruence. If you remember triangle congruence, don't worry about the video. You don't have to watch it, but it is one that I usually show in Math 1. It's very slow, but it gives a very good explanation of each of the types of triangle congruence. So if you need that, go ahead and watch it. If you don't, then don't worry about it and move straight on to the assignment.